Hi, I'm Professor Goins. Welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in college mathematics, you're in the right spot, so go ahead and click the subscribe button. That said, let's get into the current video. I'm going to talk about integration by parts, specifically just an introduction to the technique. If you haven't seen the technique before or if you need a refresher. Now, I will have subsequent videos where I talk about more complicated situations with integration by parts or tabular integration, things like that. This is just a very basic introduction to what the technique even looks like. I'm hoping that you have seen the integration by parts formula. If you haven't, or as a reminder, the integration by parts formula says the following. If I have an integral of, say, u dv, where the idea is this is going to be a product of two things, u is a function of, say, x, and dv could have a factor of a function of x, but just this integral of a product is equal to the following. uv minus the integral of v du. And the hope is that I can, by assigning u and dv to certain factors of my integral and running through this formula, that I come up with a simpler integral to compute, right? I still have to compute an integral, but the hope is that this is a simpler one than this one. Let's go through some examples. All right, let's say I look at the integral of x times e to the x dx. Okay. So I know that integration by parts is a potential technique for this because I've got a product in my integrand. And let's go ahead and see how this works. Now, the idea is I have to match this integral up with the left-hand side of this formula. So that means this is going to be equal to the integral of u dv. Again, what that means is I have to match up this whole expression with this whole expression, and I have to make an assignment. What portion of this integrand and differential is going to be u and dv? Now, the only thing that I have to do absolutely every time is the differential has to, of course, match with this differential when I make my assignments. My choices lie in the fact that I've got x and I've got an ex, so I can kind of pick and choose where those go. Sometimes we'll make good choices, sometimes we'll make bad choices. Again, a bad choice simply means that this is a more complicated integral than I started with. And I will choose it both ways so we can kind of see what happens. Again, if I have to match these two things up, I have to make the following choice. What is u and what is dv? Once I do that, notice that within the integration by parts formula, what else do I have? I've got u dv, but I've also got I've got v, and I've got a du. That means if I have u, I have to then differentiate to get du. And if I've got dv, but I know I'm going to need v, I'm going to have to do an antiderivative to get that. But once again, this first row here is where we make a choice. And the second row here is going to be a result of that choice. Okay. Well, let's go ahead and see what happens if I was to choose u to be x and then dv to be everything else. So that means dv is going to be e to the x dx. All right, those are my choices, and notice that this factor and this factor here put together is all of the original integral, or at least everything after the integral symbol, and it's equal to this product u dv. Now, the result of that is that if u is x, du would be dx. And if dv is e to the x dx, then v is going to be e to the x. And yes, I could have a plus an arbitrary constant here, but since I'm going to, when I run through this formula, I still have an indefinite integral over here, or maybe it's a definite integral. This plus c will be a result of this integration. So I'm not even going to put that here, even though it is, correct. Okay, so now what I do, if I look at this formula, notice that the original integral is then equal to uv. So that means I'm going to take the product of these two. So I'm going to multiply those. And then it's minus the integral of v du. So that means the integral of this product. So that means it's going to be that product and also an integral with a negative out front. But if I go ahead and write out what this formula would be, I have the integral of e to the x dx is equal to uv, so in other words, x e to the x minus the integral of v du, so e to the x dx. Once again, I don't eliminate the fact that I'm going to still compute an integral. The hope is that I have a simpler integral. And notice that the integral of, this was x e to the x. Notice that this integral is simpler than this one, because this one we know an antiderivative for. This would be equal to x e to the x minus e to the x. And there's the plus c that I'll use at this step rather than this step down here. This would then be my antiderivative of x e to the x. Okay. Now, again, when students are first starting this, they might not know automatically what the best choice is going to be. Let's go ahead and let's redo this example by choosing differently, and let's see what happens. Okay. Let's say, again, once again, I'm going to compute the integral of e to the x dx. And when I make my choice, I'm going to do the opposite. Okay, let's let dv be x dx, and let's let u be e to the x. Now, e to the x is simple to differentiate, x is simple to find an antiderivative for, so that in and of itself doesn't really help me out to distinguish between what is the better choice. E to the x derivative would be e to the x and then dx. If dv is x dx, antiderivative would be x squared over 2. Okay, so this is a legit choice. There's nothing inherently wrong with making that choice that I just did. Now let's see what happens. If I go to my integration by parts formula, this is going to be x squared over 2 multiplied by e to the x minus the integral of x squared over 2 e to the x dx. And once again, even though I'm saying that this is a bad choice, that doesn't mean that it's incorrect. This integral, and I did it again, didn't I? I left off the x there. This integral is in fact equal to this. And this is something that we can in fact integrate. Here's the problem. This is a more complicated integral than what I started with. Here I've got a factor of x, but here I've got a factor of x squared. So therefore, this would be a, I guess I can call it a bad choice. But I guess maybe a better way to say it is it's a less efficient choice, because I would have to then apply integration by parts twice to this, and that's just making more work than I need to do. And certainly I could make a bad choice here and then this would just spiral out of control. But the idea is, if at this step this integral is harder than this integral, go back and choose something different. Okay. That said, thank you for watching, and I will post more videos where I do more examples, but this is just a basic introduction to how to set up integration by parts and what's the difference between a good choice and a bad choice. Thank you for watching. Please consider subscribing and look for more videos.